a talk about a template that I did for a Django project, which is actually a RESTful application using Docker and Docker containers. So the main idea of this is a template project that you can feel free to use and use either as an experiment to check how Docker works or how Django works. And it also contains some tools that I have to choose my tools, so I choose tools that I was interested in or that I find nice or whatever. So it has some opinions on it. I will try to go through why I choose some of the tools that I choose and why not others. This talk is a lot about plumbing, so it's mainly about what are the things that are external to our application. So you basically have normally a core application, which is your RESTful application done in Django or whatever other system. And then you have a lot of things surrounding that, which are how do I deploy that? How do I work with that? How do I log? How do I get that in a production environment? So a lot of this project is basically about that, trying to standardize or at least make it simpler to work with all those things. The code is available in GitHub. Probably the easiest way is to search by my username, which is Jaime Buelta, as you can see. So not very original on that. So it's there. You can do PRs. You can download, use it in any way. There's also an accompanying blog post which covers some of the things that I'm going to talk here. So feel free to go there. This is a little bit of shameless self-promotion, but go to my blog and read it. This is a little bit of the structure of how we're going to talk about that. So we're going to talk first about the example application, which again is not necessarily very, very interesting. The idea is to have a skeleton that you can change and you can put things there. I'm going to talk a little bit about Docker, more in a generic view of how it's used and what are the principles that I think Docker is interesting. The architecture of the system, very briefly, how that architecture gets transformed into a Docker Compose file, some of the ideas that are baked in that I consider that are thought for using in production, so sort of production readiness checkboxes that I think you should think about a project if it's going to be production ready. Hopefully since the beginning, but you always need to add more stuff. About deploying it later, so more like, okay, what will be the next steps after you make this thing, and talking about that, a little bit of conclusions and thing. So about the application is actually a very, very simple tweet app. So it's a RESTful application. It has, you can get the list of all the tweets in the system. You can post a new tweet, and you can get each individual tweet. The tweet is basically just a timestamp and 140 characters. Unfortunately, I don't have the 280 characters yet, but that can be changed. This is really the heart of the system. That this is really what your application should be about. The only problem with that is that that's actually not the focus on this system. But this is actually the code that they pay you to write. The rest of it is more about things that you have to do. Though it's not necessarily the part that brings revenue to your system. So it's using Django REST framework. Sean in the keynote talked about that. And it's a very simple Django application. So you have, inside the template, you have a source directory with a tweet application, and then the tweet has model, test, URLs, views, migrations, and fixtures, exactly as any other Django application. The model of the tweet is very simple, as I say, timestamp, date time field, a text that contains 140 characters. The migrations have a single migration. Hopefully that will move up and get more migrations as you go. And there's this concept in Django REST framework of a serializer. So basically a serializer is a way of representing, abstracting the representation of your models. So you have a text, a tweet that is an object, a Django model object, and that gets transformed into JSON. So it's both in and out. So when you set a text, it creates the tweet, the object, and the tweet contains the timestamp of the current time, a reference that is derived from the ID, and the other way around. When you get an object, it transforms that into a JSON object that contains the text, the timestamp, and the reference. So with that, we can create our view. And the view is basically just the serializer, which describes that. I'm not going to get into details on that, but it's very simple to do. And then you have another two views, which is basically get me all the tweets, and another one that is, get me a single tweet, and another one that is the either get me all the tweets, or if you post to it, create a tweet. So as you can see there's a concept called query set, which is how should you search through, which is search all the tweets and return them, and then the serializer that you're going to use, that you reference the other serializer. The URLs there are divided in two parts. One is in source template site, which is sort of like the root of the template. You have a /tweet. Please, in this part, add everything that comes in the application tweets.url. And in the source tweets, which is the other URL, you have, if it's just tweets, tweet, return the list of the tweets or create one if it's a post. And if it's tweets plus a primary key, then return a single tweet, right? So that's nothing very, very interesting. There's also settings, and in the settings you set some environment variables, the database configuration, the login configuration, and the middleware. For this project, I'm using a Postgres database, which is also very standard in Django application. For unit test, is using PyTest. It's interesting that I show this book because you have seen that before if you have went to another talk. It's a very good book to learn about all the different possibilities that has PyTest. The documentation in PyTest is quite complete and it's easy to read, but sometimes you get a little bit lost with so many configuration and parameters and everything. So it's a good way of learning, what are the basic principles on that. pytest.ini is the file that defines what are the basic configuration, basic options that you're going to use. For example, what is the settings file that you're going to use on Django? So there's a PyTest Django module that allows you to use PyTest directly and define things like, oh, I want to use this settings file, etc., etc. Some of the most interesting options that for me at least particularly, are for Django, for PyTest Django, are the fact that you can keep the database and then create it. So a common problem, at least that I have, is that sometimes creating the database from scratch takes a lot of time. And in Django, the way to test normally involves the default one. So normally you want to keep the DB because if you do your test in isolation, you isolate them properly, you put the data there and destroy the data out after every test or group of tests. So you don't necessarily need to start the database from scratch because that generates a lot of migrations and whatnot, and that takes time. In the current project that I mainly work in my job, that takes like 20 minutes or so. So I don't want to be waiting 20 minutes every time that I want to run a test. So PyTest Django adds this concept of reuse DB. So you keep the DB and then you have create DB. That means if you want to, you can just add that and then it will create the database and keep it open. So you don't have the same problem as in Django where when they manage, you keep DB, you don't start the DB. So you have to create it, destroy the database and then create it from scratch to keep that. There's also a very interesting argument in PyTest, which is the durations, which means show me the 10 or whatever number you want of the slowest steps. The steps includes the setup of the test, the running of the test, and the teardown of the test. So that's nice to have all the time because then you will see, okay, actually this specific test takes a long time. So I'm going to spend some time trying to speed that up or whatever. Another thing that I like about PyTest is the fact that you can use just assert. So you just create a test, you say assert that this equals this, and you don't have to be using assert equal, assert greater than, or whatever. You just put the assert and something that gets to true. And another interesting part is the parameterized test, which is basically a way of saying, okay, run this test several times, each of them changing this parameter, and that's very handy sometimes when you need to check that, a single test, maybe with different inputs or something like that, and all the time is returning the same thing. So you just want to be sure that you're capturing all that information. About Docker, one of the things that are important thinking about Docker is that it's sort of a paradigm change, which is something, the kind of thing that someone in a black screen with white letters and will say, and everyone will be very excited about. It's still a little bit of an overstatement, right? But it's really something that is changing and probably will change more the way that we do web apps and we deploy things. So it's probably worth investing a little bit of time on thinking of that. One thing that I've learned recently, just talking about all the containers thing, is I am interested, and I've been reading quite a lot about physical containers, you know, the big boxes of metal that they put in ships. And it's an incredibly fascinating story that I highly recommend to everyone to get into that, because it was really, really, really a huge revolution in the way merchandise and goods were moved around the world. And it came from, you know, like, hey, what a great idea. I'm going to put everything inside the box, and the box is going to be exactly the same size. And but all the implications that has from the point of view of how the docks change, how the ships change, how the movement of goods change, is pretty interesting. So I will recommend, if you like to hear a little bit more about that, there's a podcast called Containers, surprisingly, that is very good and gives like a good you know, view of all that. So when I started thinking about containers, my first impression was the containers was lightweight VMs. And then it got incredibly frustrating because they're not. So normally when you start with a server, and I'm calling this sort of fat traditional server, the main idea is that you have some workers that are doing some work. You have a load balancer maybe on top of that to be able to spread the load between the different workers. And then you have a lot of things that are auxiliary to that. You have a config agent, you have syslog, you have monitoring tools, you have dev tools maybe if you need to check them. You need probably access to Git to be able to get the code, a way of injecting the code, SSH access so you can enter and the people in ops can enter, and that's a standard, blah, blah, blah. And maybe if it's a development environment, you also have your DB and cache inside the server and everything. That was sort of my initial approach to Docker, just cram everything inside the container. And the problem is that doesn't work. Like, that's not the proper way, in my opinion, to use Docker. I think that the best way of thinking of containers is a process wrapped into a file system. So you get your process, which is maybe a web server or maybe something else, and then you have a full file system surrounding that. A full file system means that it should only have the things that are either required by your operative system or required by your system. So normally, for example, if you start a process that is Apache or whatever, you include the configuration file for Apache. If you have a small file system and you include only the things that you require for that specific process, you keep a small container. And a small container is something that is, I think, very, very useful to try to get, because what happens is when you start getting more and more containers, the bigger the containers are, more space are you using everywhere, and more time they take to download, and more time they take to push, all that kind of stuff. And if you're using a lot of stuff that is just, you know, dead weight, that you're not going to use it, just try to remove it. Another thing that happens is that once the container stops, the container disappears. It's not live anymore. So thinking of that as a container with a file system, to me, is a more natural approach to that, because it either is running the process or it's not. And that's it. That's all the container is doing. That process is not necessarily the only thing that your container can run, and that's why I put those asterisks there. But those should be something that are completely accessory. Like the main process is something that you need to keep in mind. What is my main process on my container? And making the decisions after that. The other thing to take into account is that each container is a single part of the puzzle. You can't really work with a single container. if you try to replicate the server that we showed earlier, you can't do that with a single container. You have to use more. So containers forced to think in clusters since the start. And I think this is a change that is, quite noticeable when you're thinking about how to work with containers, but also it's a good thing because potentially at some point you will deploy your system somewhere and that's going to be a cluster. That's not going to be a single server. That's going to be something that needs several pieces to interact with each other. So you're sort of baking that since the beginning, because when you're starting your system and developing it, you're thinking, oh, I need 3 containers because one is going to be the web server, the other one is going to be the database, the other one is going to be a log system or whatever. And then you're thinking that since the beginning. You're making that more explicit. So instead of having that for developing, hopefully a Vagrant VM, it could be also a VM done manually, but let's say you have gone to the state that you're using Vagrant, so it's replicable and everything. And you have one service 1, service 2, service 3. You have some configuration, you have an embedded database there because you need that to make tests. And you have some dev tools like Git or whatnot to be able to enter there and treat the code and have all your tools available that you love. You need to change into this. Each service is their own individual container. Each database is in its own individual container. And if you have cache or you have something else, is inside. And things like developing tools are not part of the internal container. Like they're on your computer, or maybe in a different container that is never going to be deployed, because you don't need that to deploy that. Like you only need that while you're working on that. So sort of the basic idea of working with that will be at build time. That's the time where you're building your container. You put your code, you put the packages that you may need or any dependency. You compile something that you may need to compile. And then you have your container. You close your container and that's it. That's the container all the way down. If you need to run tests, which hopefully will be the first thing that you will do, you just call an environment, you set up an environment that is an environment for unit test or whatever, and you call the execute test command inside the container. The container runs the test, then you say, okay, there's a J or an A. If you need to do integration test, you start all the containers, because probably only one container is not going to be enough. You put your environment for integrate them, and then you run the tests. And once you have that in production, you just need to change the environment. So that means that you have an immutable container that is always the same, and a mutable environment. So you're very, very explicit about, hey, this package is not going to be installed in production because I don't need them. And I think, it's sort of like a methodology of forcing you to think about those things. And, we know in the sense of Python that explicit is better than implicit, and that helps, it's a little bit of putting a strain where you're thinking about everything, but it's better long term because, you have everything pretty much nailed down, where the parts are in production and where the parts are in development. Talking about the specific, this specific template, my idea is to do a self-sustainable or self-reliant, stateless HTTP server. So it directly accepts HTTP requests instead of any other kind of access. And it's just the container, just the HTTP server. So you can put that on top of the load balancer. It opens port 80, which is a standard HTTP port, and then it connects to the database and other stuff that we'll talk about that. So the basic architecture, this is for the project, the template, is this. So this is the container. The container contains the main project. The main process is the uWhiskey process that sets the Django code. And then there's another one, which is the Nginx, that helps serving the static files. So, and there's also another containers, one that has the database, another one that is a syslog container. So we send all the log to that syslog container. And there's another one that collects the metrics. We'll talk about that a little bit later. There's a simplification that I want to do, but I have in another branch, but I haven't merged that into master, which is just use uWhiskey, because uWhiskey can serve static files. So we can expose uWhiskey just in port 80, serve the static files and use Django, and the rest is the same. So it's simpler and probably for a template is better. So we are going to talk now about how to work with Docker Compose to get that general architecture into a specific configuration in that. So Docker Compose, has anyone worked with Docker Compose before? Okay, not too many people. So Docker Compose defines something called services. The services, which is roughly the containers that are going to run. You can run a container multiple times, but each one contains basically this: the build information, which mostly is pointing to a Docker file. The dependencies, that means if this container is started, maybe there's another container, another service that needs to start first. And then the execution info. Do I have any environment? Do I want to overwrite the entry point of the container? Something like that. So in the build process, basically is the Docker file. The Docker file is a file that defines how to create the container, basically. And the main structure is you have a base image, which is the image that you start with. You have some build steps. So, you add code as you go, you install something, you remove something. And then you have a runtime info, which is the default entry point if you expose some port, something like that. That's basically what the Docker file says. So as a base image, I like to use Alpine Linux because it's very, very small. So we talk about the goods of having small containers. If you start with a base image, something like Ubuntu, you use, normally like a VM. You install the first version, which is the Ubuntu. You do an apt-get update. Then you install 3 packages. You install Python. You install maybe uWhiskey. You install Nginx. And suddenly you have an image that is 800 megabytes of size. And that's huge. And most of it, you don't need it. So if you use something like Alpine Linux, the base image is just 5 megabytes, which is amazingly small. But really, when you install Python, that's 70 megabytes. So it's normally you end with images that are around 100 and something megabytes, at least for these template. But it's still 8 times smaller than something like Ubuntu with the same things installed, because that's installing a way more stuff that you really need. You just need almost a Python interpreter that is running something. So about the running steps that you have, you can do things like install a package. In the case of Alpine Linux, it's use something called add, but it's basically just an apt-get. You can install packages that has a lot available. You can add files directly from your source code. So you add your source code, you add some script, and then you can run those scripts if you want to do things. So one thing that happens with the file system is that the Docker file system works sort of like a git commit thing. So every time that you perform an action, that action creates a layer. So if at some point you want to remove something, it doesn't matter because it really removes the previous layer. So if you want to do some step that deletes thing, you have to embed into the same step. So you do in the same step, you add things, for example, you add compilation tools, you compile, and then you remove the compilation tools. And then you don't keep the compilation tools. For example, for building the database container, which is one of the most complex ones, the base image of Postgres, it doesn't really matter for that. You want to have a container that when you start, you have already your database with your database schema, and you have your fixtures to be able to test. So then when you start and stop the container, you start from that fresh image. You don't start with a completely empty database. So the Docker file, what it does is install database, add your code, create the database, so now it starts a fresh database, runs the migrations, copy that to the test database, so you have a clean test database, loads the fixtures into the general database, and then you have it already baked. And every time that you start it, you start from that point, not from zero. To be able to do that, because Postgres is not really very amicable to these things, you need to, in the same process, start the database as an independent process, run the commands, which is load the fixtures, and then stop the database. The main Docker file, which is the main of the project, you need to install the main dependencies. The process that we say, compile tools, install dependencies, remove the compile tools, you add the code, and then you add the sec info, which is basically what is the entry point and what are the ports are exposed, port 80. When you're creating the Docker file, another thing that is interesting is the fact that because you work in these layers, those layers are really cached. So every time that you need to change a layer that is on top, you need to run the other ones. So if you work with the structure of the Docker file, you get much better times, because if you only have to change the latest layer, that's the only one that you need to repeat. While if you change the first layer, then you have to repeat the first layer from there on. So it's interesting while you're developing on it to tweak the order sometimes, and then keep them the final order in a different way, depending on the area of the Docker file that you're working. So the services that for the template that we have are server, which is the main container. We have the database, we have the log, we have the metrics. There's also an external one that is a Grafana container, but that's basically as more like an example. So you can connect that to the metrics one to get better graphs if you want, but that's the default one only. And other than that, there's also some auxiliary services that are also services, but are not thought to keep the container running. For example, running the test. So running the test, it just runs the test, the process ends, and the container is done. Integration test, it happens the same thing. If you have already the other process open, it runs the integration test and that container ends. And there's also generation of wheels, which is just a cache thing. It just creates all the dependencies that the other project has as wheels, so it pre-compiles them. So when you create the main service, you already have that as wheels, so it doesn't need to add compile things, and it just speeds up the process. One thing that I also added was the using submodules. So a problem that you can have is that you have some dependencies that comes from a different repo. So what happens with that, and sometimes the traditional way of dealing with that, is that in your VM you have a Git that connects to an SSH server and then downloads that. The problem with that is that obviously inside the container we don't want to put Git, we don't want to put SSH keys that are private, all that kind of stuff. So the way of avoiding that is pre-download that as a submodule in Git, so it's sort of a dependency in Git. Submodules in Git are really weird, way more than general Git. I put some documentation in the template if someone is interested. It's something that is even weirder than normal Git, that has some problems, but it's something that it's worth looking into. Then there's also an environment file, which is basically the dev environment. So when you run the template, just to start it, it has the dev environment and it connects all those dots together. There's also another thing called args, which are just environments at build time. So it's just an entry point for your Docker file to be able to compile things. For example, what is the password of the database? Obviously, that needs to match. The password of the database when you create the database needs to match the password of the database when you set that in the environment file, or the database won't have it won't match. So once you have that at build time, normally you just have an entry point, which is a script that the only thing that does is prepare that. For example, start the logging and channel the login to the other container, set up some config file, something like that, and then it runs the command, which normally will be uWSGI or Postgres or whatever. The structure of the template is you have a Docker submodule that has a lot of subdirectories, each one for each of the services, and all the related information like scripts and everything inside that. And then there's a general Docker Compose file, which is the one that we talked about, and a general Docker file, which is the one that creates the main container. That's done to allow doing Docker Compose run, and then it will run the default one instead of putting that in somewhere else. So some of the things that I've included, which I think are more related to production readiness. Logging. So logging is a big thing, I think, and I think it's extremely useful if you're thinking of products, because normally gives a lot of information when you're running them. So getting good logs is important, in my opinion. So there's a container that is just the place where all the rest of containers send their logs to, and then you can execute the Docker Compose tail. Basically you execute tail on that on the logs, and then you can see the logs of all the system. So that's pretty handy when you're running something like integration tests, because you can see what is the behavior of the whole system. Another thing that I recommend is log while you code. So if you're running your test and everything, you create the bug logs to know what is going on. If you use print as a way of debugging things, instead of putting prints, you can put logs. And then you can keep some things there, and when something happens in production, you will have them available. Then add descriptive error warning and info in whatever level that you think is interesting. And also be sure that you're capturing errors that you don't expect. So spend a little bit of time running tests saying, hey, what happens if there's a while exception? Be sure to capture those, because in production it's going to be interesting to have that information available. Other thing that is I consider like production readiness is metrics. So in the template is adding Prometheus metrics in the metrics URL, base URL. So Prometheus, in case someone hasn't worked with that, is a very powerful way of getting metrics. It's also a little weird. So it has a weird way of getting things, and it's also a very opinionated product. But the good things it has is that it's very powerful to create in alerts. So you can create alerts very easily to say, if this reaches this level, blah blah blah, then it creates an alert, and then people in ops can know very sure. Or this has been erroring for this amount of time, that kind of stuff. Another thing is you can federate them, so that means you can cascade the metrics and put different metrics on different levels, and those will get carry over. So it's good as a way of distributing the load instead of having a single server that has to accept all the metrics by everyone. It also accepts displaying the metrics in Grafana, which is a great way of showing graphics. Some words about graceful operations, which is how to ensure my system works fine, and if it's not working fine, I know, and if I want to kill it and restart it, it does that gracefully. So one main thing is having a health check. So a health check, there's a concept in Docker that is the health check. So you can define that a container has a health check, which is basically a command that you define that runs periodically on the period that you say. So in this case, if you add a health check, which is added in the template, just as a way, okay, I ping the database, everything seems to be working fine, I return 200, and you do a curl on the locally to grab that, and then you put that in the container, and the container is doing that periodically, and there's a native understanding that this is a health check, and you can continue with that. So I think it was interesting to add that. The other thing is trying to make the system to gracefully terminate. When you say to a container, hey, stop, because I want to create another container, I want to do whatever with it, what Docker does is sends the seek term to the container, to the process that is open, and in, I think, 30 seconds, if not, it will kill the container for good. So it's good to capture that signal, and then with that signal capture, then you kill gracefully your operation. So this is a snippet of the star server.sh. What it does is it defines a function which is then echoing Q to a uWhiskey FIFO. So uWhiskey FIFO is a special file that you can send commands to uWhiskey. Q means gracefully terminate. Then you trap the signal seek term. Then you start uWhiskey, and then you wait until uWhiskey ends. So that wait basically means, hey, you have started uWhiskey as a background process, wait until it is killed. So that way, instead, when you do Control-C, instead of having to wait those 30 seconds, because you're not capturing the signal, and then at the end it sends a kill -9, instead of that is gracefully killing the process, and hopefully you're not in the middle of a transaction. So some ideas about, once I have this template and I use it, and so far everything is very focused on development time. What should I do after that if I want to use that as an operations tool and as a way of deploying in a real production system? So the way I envision that, it will be trying to make more of a pipeline. The things that we have been talking about of, okay, I run the unit test, I run the integration test, continuous integration and delivery. So you basically push your code, your container to a registry, a Docker registry, and then you have a pipeline that is extracting that and giving on the result of the stages, is passing stages until finally it gets deployed. Hopefully, if you have continuous deployment, that's a lot of work actually. So yeah, just to get that, but that's more or less the general idea. And there's also another important part, which is what are you going to use to orchestrate it? Because Docker can be deployed in several places. So far, the options at least that I know are Kubernetes. There's an option of doing a compose. There's a compose module that basically gets your Docker compose and transform that into a Kubernetes configuration. It doesn't support everything, but it keeps adding more stuff. Now Docker has announced that they are going to support Kubernetes natively, so I don't know exactly how they're going to do that, but it looks like maybe Docker Compose is going to work. Docker Swarm, that is the alternative that Docker itself is pushing for, and is basically using the same Docker Compose file with a couple of changes, but everything that is supported. Mesos Marathon, which is another alternative. I don't have that much experience with Mesos Marathon. Another important part is the secret management, because when you deploy things in production, you want to have things that are secret, like your key or whatever password, or the base of how you handle the passwords or whatever. So normally, one way that you can do that is to create them as environment. For example, Kubernetes works like that. So inside your code, you just grab the secret from the environment. There's another way, which is the Docker secrets way. So that's the native Docker way of handling things, which is you define a secret in the Docker Compose file, and then it generates that as a file in the run secret. So you can work with both. If in the start script, you then export that. So you just basically get whatever is in the file and put that in an environment file, and then you can grab it from the environment. So that's a way of sort of working in the same way. The other thing in the production is that not necessarily everything needs to be Dockerized. So for example, I've never seen exactly what is the point of Dockerizing a database. Like a database is probably something that is going to be very, very stable, that you don't want to change so often, and that normally just connects and the API is very, very stable. So I think it's good to have a fast-paced environment on cluster for your containers, where is the web apps and everything, and you're just constantly pushing and try to get new features as fast as possible. But the database really doesn't change that often. So I think it's not necessarily that the database can work as usual with a server, or if you want to use something like Amazon or whatever. So a little bit of conclusions in that. The main one is containers are not VMs. I hopefully have convinced you all. I don't know, I'm pretty sure I will still make some mistakes on that, but it's worth to try to find out what is the difference and what is the different way of working with that. The other thing is that it's good to log what you test, because then you are naturally including in your routine to add things that are useful in a possible problem in production, which I think is a good thing. And another one, which is like plumbing, is a lot of work. There's a lot of work involved in this kind of setup your application, which is not necessarily the main objective that you're doing. Is not a feature that you can sell to someone and say, hey, actually I'm deploying very, very fast, and that's awesome. And what are your features? I don't know. But it's a lot of work, so it's something that we need to appreciate and prepare for that, because just running services on production is really difficult, and you want the plumbing in your house to work all the time reliably. So just a brief recap. So we talk about the application itself, that again is a very simple application. It's just a tweet thing. You can go there, you can download it, you can play with it. Some concepts on Docker itself. A brief architecture, how the template is structured, how that architecture gets into a Docker Compose file, and what are the different parts of the Docker Compose file. What are some features that I consider that are important for production and they have been included in the template? What are the next steps if you want to move forward and to deploy the test? and a couple of conclusions. And that's it. So thank you very much for your attention.